Alright, so we're going to start with a review of some of the algebra from the previous section in the in-between test. So let's look at page 384 and number 5. So it's 384, number 5. And it looks like it's a word problem, right? Okay, so it says, for a 2-week period, Jan earned 150 less than twice Tom's earnings. Together, Jan and Tom earned 1,380. How much did Tom earn? So there's two ways we can do this problem. One, we do algebra. The other way, we do each answer, we test to see if it works. So first I'll do the algebra way, and then I'll do the testing way. But either way will work. So first of all, let's just have a look here. We have Jan, we'll do as a J. I say Ja because it looks like a Scandinavian name, and they say the J is a Ja. But you can say Jan if you want as well. But to me, that name is Jan. Anyway, so Tom is T. Okay, so Jan earned, so Tom we have, it says Jan earned 150 less than twice Tom's earnings. So Tom seems like the base, right? So we'll make Tom X, okay? And now we'll write Jan in terms of Tom, okay? And it says it's 150 less than twice Tom's earnings. So Tom's earning is X. What is twice Tom's earnings? Well, 2X. Twice is 2 times, right? So it's 2X, and it's 150 less than that, right? So we subtract 150. Right? So here we have, this is Tom, and Jan is 2 minus 150. Because it's 150 less than twice. Do you remember when we had those, like, how to write math in... That's what's happening here. That's what I'm doing here. And why did I choose to make Tom X? Because it seems like it says Tom is like the baseline, the easy one. And Jan is being written in terms of Tom. So it looked like which one is being written as a relationship of the other one. And the other one will be my X or my Y or my B or whatever, my variable. And then I'll write the first one according to that relationship that they talk about. So here we have Jan and Tom. Okay, and together they earn 380. So J plus T equals 1380. Alright. Now we know J and T in terms of X, so we can put them in and solve for X. So it becomes 2X minus 150, and this is J, plus X. Okay? This is the challenging part, right? Getting to here. Once you have here, you guys can solve for X. Okay, so this is J, right? And this is T. This is Jan, this is Tom. And together they equal 1380. So now we can solve for X, right? So it's 2X minus 150 plus X equals 1380. 2X plus X, 3X. So 3X minus 150 equals 1380. Alright, now we want to get X by itself, right?
Plus X.
So first we want to get rid of this 150. Okay? So we add 150 to both sides. Okay, so this becomes just 3X. Because these guys cancel. This is not a good X. 3X. And what is 1380 plus 150? Alright, so this is 0, this is 13, 3 with a 1, so 1530. Alright? Okay, now we want X by itself, so what do we do? Divide both sides by 3, right? So over 3, over 3. And now we have X here, all by itself. What is 1530 over 3? Yeah, because 3 goes, you can see 3 goes into 15.5. 3010, so it's 510. I think you're allowed to use your calculator. Yeah, you could have done it on the calculator as well, if it's a more complex problem. So now X equals 550. That means we have Tom. This is where you have to check the question. Is it asking for Tom, or is it asking for Jan? If it's asking for Jan, we have to put X back into here and solve for Jan. Right? But it says they're asking for Tom. Right? So therefore we have X. So therefore C. Tom is X. which equals what, 510. Alright, so the answer is C. Did you guys see that? I'll tell you that. Welcome. Now the other way to do it is to test with all the answers, right? So the other way we do it, we can say, okay, let's look at A. A says that Tom is 320, okay? And therefore Jan is 150 less than twice Tom. So we have to test it. What is 2 times 720?
1,440.
So 2 times Tom equals 1440. And Jan is 150 less than that, right? So Jan equals 1440 minus 150. Okay? And what does that equal? Pardon? 1290, I think. We can do it here. We practice some of our long, right? 0, we have to cross that to 3, put a 1 here. Becomes 9, 3 minus 1 is 2, 1. Yeah. Okay, so now already I know that this plus this is not 1380. Right? This is too big. So I know it's not A. So not A. Let's try B. Right? B says Tom is 660. So again, 2 times Tom is what? 660. You can use a calculator for this, but you can do it in your head too if you want. So this is 1320. Okay? So Jan is then 1320 minus 150. Again, we can do that here, or you can do it in your head. Yeah, it's 1080, I think. So 0 across that becomes 2, 1 are 70. 1, 1. Okay? So Jan equals 1170. Okay, so then Tom plus Jan equals 1170 plus, what did they say? 660. That's also bigger than 1380. Right? That equals like 718, 1830, I think. Yeah, so not B either. Okay. So we then can try C. So this way can be long if it's one of the ones further down, right? So C says that Tom is how much? 510. Okay. So that means 2 times Tom is what? 1020, that's right. Then that means Jan is 1020 minus 150. Right? Which equals, you can do it by a calculator or you can calculate it. 20 minus 50 is going to go down to 70. So it's 970 minus 1 is 870. 870. You can do it on a calculator, you can bet as long if you want. 870. So then we add these. Tom plus Jan equals 870 plus 510. And that equals 1380. Correct. So it's C. And if that was wrong, then I'd know it was D. Right? I don't have to do the calculation. That's something with these. If you get all the way to C and you've proven A, B, and C are all wrong, don't do D, just say it's D. Because otherwise you waste more time. Unless you have time. If you have time, you can check. But you probably won't have time on the test. But if you really want to do it to make sure you show yourself, do it. But most of the time, you're probably right. Just do D and keep going. Right? It's like you've got to strategize with this test as well. All right, any questions on how to solve this one? I think this one was faster, actually, the way I did it. But this one you don't have to kind of, if you can't figure out how to translate this into algebra, you can try to do it this way as well. Right, let's take a picture of that. Okay, so the next one is number 8, right? Okay, number 8 is also a word problem. All right. Okay, Samuel is paid $350 per month plus a 10% commission on his total sales for the month. If he needs to earn at least $2,100 per month, which of the following expressions represents the total sales for the month Samuel needs to achieve? All right, so we have, let's just put Samuel S as $350 per month, right? Here's $350 per month plus 10%. What is 10% in decimal? 0.1, right? Times sales, right? I'll just put a little x. Times sales. This is his earnings, correct? So what they want to know is, how many sales does he need? So we need to know what sales he needs in order to get this total to equal 2,100, right? In 1 month. So really, we don't need to worry about per month. We're just adding this 350. This is a constant in this one. So what this is that basically the total has to be greater than or equal to, right? He has to achieve that. He can go more. He has to get minimum of that. So greater than or equal to 350 plus 0.1 times, I'll put it as S. I'll call it S. S for sales. Okay? Our variable is S. And now we need to solve for the total has to be 2,100, right? Has to be greater than or equal to 2,100 plus 0.1 s. And now we solve for s. Does everyone see this?
Yes.
Okay. So first of all, we need to get s by itself, right? And remember, when you're dealing with a greater than or less than, you treat it like an equals. Unless you don't divide or multiply by a negative number. Then you turn it. Remember that?
Yeah.
Okay. So we want to get rid of the constant here. We want to have just something in terms of s on this side. So we subtract 350, right? Subtract 350 from both sides. What's 2,100 minus 350? It's 2,000 minus 250, right? Which is 1,750. Okay, and if you want, I can do it here. Minus 350. Yeah. So 0. This one we need to do is a 0, we put a 1 here. 5, this one we do a 1, put a 1 here. 10 minus 3 is 7. 1 comes down. 1,750. Okay, so this one is now 17. Well, let me get a marker. $1,750 is greater than or equal to 0.1 s. Okay, And by the way, this is why as soon as I wrote it down, I put it in decimal. For me, I always try to convert the percentage into a decimal because it's a lot easier to work with. And you don't have to worry about it converting it later. As soon as you write it down, just convert it into decimal. If you need a percentage at the very end, you can always put it back. Okay, so now we have S and here. So we need to get S by itself, right? So, what do we have to do to this to get it to equal 1? There's two things you can do. One, we divide by 0.1, right? Or we multiply by 10.
It's a percent, yeah?
It's a percent, yeah. So 0.1 is 10% is 0.1 in decimals. So I'm writing it as a percent because it's as a decimal because it's easier for me to work with. Okay. So you could do it either way, because if you did in your calculator, we're allowed to use the calculator, right? So honestly, something like this, use your calculator, because then you can be sure of the answer. All right. You just put 1750 divided by 0.1. You can try it. Or you just move the 0, 1. Right? So this is 7,500. Like that. Okay? Or what you can do is you can say, you know what? I have this here. Right? 0.1s. I just multiply both by 10. Right? And that'll give me S here. And it'll give me the same thing here. Or you can say I'm moving this one here, so do the same on this side and move it 1 here. Right? It's the same kind of idea. But in the end, you're going to get S is less than or equal to 1750. You have to look at this one because I got it switched. So let me rewrite it the other way around. S is less than or equal to 7,500. Okay. That's strange to me. Total sales for the month. Total's greater than. Because sales are less than or equal to. It should be greater than or equal to, I feel. But where's my negative? Ah, I did it wrong from the beginning. This should be this way. Sorry. I was looking at it, like, this doesn't make sense, right? It's supposed to be bigger. Right? I was looking at this answer and I said, less than or equal to doesn't make sense. It should be if I make more sales, I make more money. Right? Not less money. So I looked back here and I realized, I said that the total, this has to be greater than 100. So I got this one wrong. So it's actually supposed to be, this is greater than or equal to, greater than or equal to, greater than or equal to, and here S is greater than or equal to. And this is a problem because you see we have B and A, right? So this is something where if your answer doesn't make sense, check it, right? Because I was looking at this and I said, it doesn't make sense to me that S is less than or equal to. Because that means the bigger a sale means you're making less. That doesn't make sense. It should be bigger. So I figured out I'd written it wrong. This thing is supposed to be bigger than 1/1200. Okay? So this is
B.
A. That's right. A. You could do it the other way around as well. And in this case, the other way around will probably be faster because it's A, right? So the other way is we say, all right, let's say the answer is, let's start with A. Say the answer is S is greater than or equal to 17,500. Okay? Then we say, what is 10% of 17,500, right? 10% of that is 750, right? And he also gets $350 a month. So we do salary equals 350 plus 1750, which equals 2100, which is correct. So we know this one is right. It has to be more than, so it's greater than. So that means we need salary has to be greater than or equal to this, which is what we want. Any questions on that? Okay, here's my phone. So in this case, it was quicker to test each answer than to do the algebra. And in fact, it may have been quicker even to do all 4 of them this way, just to check them. You have these 2 methods. You can try either one. It's good to know both. All right, let's do number 11. That's on page 385. Number 11. Is it also a word problem? No, it's an inequality. Okay. So which value for x makes the inequality x greater than 400 true? All right, so this one we do have to just go through each one and see, right? So a is 7 to the power of 3, right? So what's 7 to the power of 3? You know what that is?
49 times 0.
Yeah, so it's 7 times 7 times 7, which equals 49 times 7, which
340.
you can use your calculator. You got 343. All right, 343. How I would do this in my head is 50 times 7 is 350. Take 1 7 away for 49, gives me 343. Okay? Is this greater than 400? No. So not A. All right, let's try B. In fact, there's a problem here. Oh, no, we're fine. Let's try B. B is 4 to the power of 4, right? So that's 4 times 4 times 4 times 4. You can use your calculator to get it. If you want, it's basically 16 times 16, right? Or 16 times 4 is 64. Right, so it's 64 times 4, which is 240 plus 16. 252?
256.
256. Yes, 6. 256. Is that greater than 400?
Yes, yeah.
It's not.
No.
256.
Yeah,
Greater
it's
than
not
400.
less.
Oh, less. Okay, I thought you said you were agreeing it
No,
was
I
better.
said it's
Okay.
less than 400.
Okay. Yes, it's less than 400. So no, not D. Let's try C. Is 3 to the power of 6. That's big. It's gonna be a lot. They're kind of showing you, even though this number is smaller, the more powers you have, it's bigger.
Yeah.
Now, I actually instantly know it's C already. Because D is 6 to the power of 3, right? And we already established that 7 to the power of 3 is too small. So 6 to the power of 3 is also going to be too small. And since I now know that B, 4 to the 4, is also too small, it has to be C. So I could have just at this point already, having done these two, I can say C and move on. Okay? But because I know you guys want to do the math, let's do the math. Alright? So this equals 3 times 3 times 3 times 3. That's not it. Yeah, 6 times. 1, 2, 3, 4. 3 times 3. So you can put it in your calculator. 6 exponent, 3 exponent 6.
729.
729?
Yeah.
Yeah, let's just do that. And that is bigger than 400.
Yes.
So it's C. C is the answer. Any questions on this? This question really is about exponents more than algebra, right? And if you can do the calculator, remember the calculator you do like, I think it's the X, that symbol, right? So you put 3, and then you do this symbol, then you put 6, and it'll give you the answer. All right, any questions? Let me take the picture. If not, then let's move on to the geometry. But feel free, I encourage you guys to do some more of these questions this week. And next week, if you have more questions on them, feel free to bring them and we can go over them. It's very good to do review. Okay, now 389. I think the earlier ones were clear. It's just like 1 through 10 is basically what is the name of this, right? And you guys got all those? It's not a problem for these ones? 1 through 10? Okay. And I guess if not, you just look in the back of the book and you know the name. There's nothing really more I can do about that. So let's do number 11, right? So number 11 says we have this figure. It looks like this. Okay. And we have a little corner, a little square here, a little square here. E, F, G, and H are the corners. There are also something called a vertex, but we'll just call them corners. And what does this little square thing mean?
90 degrees.
It's a 90-degree angle. Okay, when you see this square thing, it means it's a 90-degree angle. It comes at an exact square like that, like the wall to the floor. That's the 90-degree angle. All right, so the question is, it says angle F. So F, and here's the symbol for an angle. Angle F is 3 times angle H, right? That's what it says. What is the measure of F? All right. So, let's say that if this is, what we have here is angle F is 3 times angle H, okay? So we don't know what that is, but we do know what these two are. And we also know one other piece of information about a quadrilateral. What is that piece of information about the angles? Does anyone remember? 360. All the angles add up to 360. Right? If it's a 4-sided figure, all the angles, no matter what they are, they all add up to 360. So what we know is total equals 360, right?
Yeah.
Now let's make angle HX. Right? So this is X. Then this one is 3X.
It's 20 more. It's
All right.
here 20 more than 3.
20 more than. Oh, thank you. Sorry, so this is plus 20.
Yeah.
Okay. So that means it equals 3x plus 20. Alright? I'll put that here anyway. 3x plus 20. Okay? So now we can add all these together equals 360, right?
Yeah.
So 90 plus 90 plus, I'll just start with the x.
Yeah.
X plus 3x plus 20, right? Equals 360. Okay? And then we solve for x. Alright, so first of all, let's just take this one out of the brackets. This is 180.
Like
Yeah, plus x plus 3x plus 20 equals 360. 180 plus 20 is what?
200.
200. And x plus 3x?
4x.
4x. So do you see why we learned algebra first? Right? Now we can do these things. That equals 360. So that's good practice of algebra here. Now we want 4x by itself, right? So what do?
Minus
Minus
200.
22.
Subtract 200 from both sides. That's right. See, you guys are You know how to do this. This is not just like natural. Right? This is what happens when you practice, right? You practice it, you practice it. You see this, you say, oh, I know what to do. Right? Okay, so now we have 4x
160.
equals 160. All right, what do we do next?
40.
Divide by 4 each side, right? Each side divide by 4, and we get x
That's what 40.
equals 40. All right, that's the answer, right? 40. No.
What? 24.
The question says, what is the measure of f? All right?
Okay.
So f equals 3x plus 20. Now we know x is 40. 20, right? 4 times 3.
120.
120 plus 20
140.
equals 140. All right, is that an option? It is C. But you guys are tempted to do A, right? You have to read the question.
Yeah.
Especially on these kind of problems, when they have the two things and one is in the other. Sometimes it's the x, sometimes you have to solve the other one. Right? So just make sure you know what the question is asking. All right, so that's C. Any more questions on that? Number 12. I think I'll try to do it in this space here. So it's the same figure, right? And it says in order for this to be, oh, okay, it's just like asking about it. So in order for this to be a trapezoid, which of the following must be true? All right. So for this to be a trapezoid, what does it mean to be a trapezoid? That's the first thing you need to remember.
Only 2 lines are parallel.
2 lines are parallel. That's it. You don't need anything else. And actually, to be a trapezoid, it means that only 2 are parallel. All right? So, what this means, let's see. Basically, these two have to be parallel, right?
Yes, yes.
So for A, EF is the same length as FH. That has nothing to do with being a trapezoid.
No.
Okay, the second one, EF is parallel to GH. Do you see this symbol?
Yes.
This is an important symbol. A, no, B, EF, these 2 lines like that.
Yeah.
You see that? To GH. This means it's parallel.
Yeah.
All right? You can see the 2 lines, they're straight next to each other, right? So kind of in the lines, those 2 lines are parallel to each other. So that's how you can remember that they mean parallel, because they are parallel.
And also the 90 degrees down here and up there gives yes as
So you know, if this is 90 and this is 90, you know it's a parallelogram,
Yeah.
I mean a trapezoid, because it's,
yes.
yeah, it has to be. Okay, so this is correct, so it's B. We don't need to continue. If we look C, angle F equals angle H, not necessarily. Next to angle G equals angle F.
No.
You don't need that either. For a parallelogram, that would need to be true, but not for trapezoid. All right, any questions on this? No? All right, then let's do number 13. Take the picture. Right, number 13, we have what looks to be a square. All right?
Yeah.
Let's see. 13. Okay, and it's RSTU. That says 5 centimeters.
Yes. Oh, yeah.
Or is 5.
All is
Or
5.
yeah.
Okay. So we know for sure that all these are 5. Does this mean it's a square if they're all equal?
Yeah, it's good.
Not necessarily.
Why?
You can also have a diamond with 5, 5, 5, 5. Okay?
But 90 degrees.
But it doesn't say it. This is something important for algebra, for the geometry, okay? If the figure is drawn on the page and it looks like it's 90 degrees, but they don't put a square thing there, you can't be sure. Alright? It can be tricky. You have to go with what they give you. Now, yes, this definitely looks like a square. And if I measured the angle, I would, if I had the angle measure thing,
Yes.
it would be a 90-degree angle. But in mathematical problems, okay, unless they tell you what the angle is, you cannot assume. Alright? Because sometimes you'll look at something and you'll say, oh, it's a parallelogram, but it might not be. And maybe your vision may be a little off. Okay? But if they put like a thing here, then I know it's 90 degrees. Alright? But they didn't, so it could just be a diamond that's almost a square. Right? This could be 88 degrees, and this one 92 degrees. Right? They could be really close. It would still look like a square to me. It would look like a square to you. But unless they tell you exactly, you don't assume it. But I think it doesn't matter for our question. I'm just wanting to, oh, look here. It has on the bottom. So you're right, it is a square. You should have told me, there's 90-degree angles.
Yeah, so yeah, but it's okay.
Yeah, oh, it's good lesson,
good,
right?
yeah.
Okay, so now I know for sure it's a square because we have these two, right? If this is 90 degrees and this is 90 degrees, this one has to be 90, this one has to be 90. So the whole thing is a square. In some ways, the square is kind of like the most perfect quadrilateral, right? It's the most even. Has all angles the same, all sides the same. It's exactly equal. So what do we have here? If the opposite sides are parallel, right? If this is parallel to this one, what does it want to know? The measure of angle R.
90 degrees.
So R has to be 90, right? Because if these sides are parallel, then it means this is a square.
Yeah.
Although already, even if you have 90 here and 90 here, you know these have to be parallel.
Yeah, exactly.
Alright? Because it's 4 sides. This is 90, this is 90. So these two have to be 90. If this is equal. If this was bigger, then they wouldn't have to be. But if these sides are equal, which you know, then this has to be 90 degrees. So, if this is parallel to this one, then this one has to be 90. So R equals 90, which is what? C. Any questions on this? Okay. Move on to take a picture, move on to the next page. Okay, so 391. Triangles. Alright, you guys had number 7. The rest were clear? Right? Number 1 is an equilateral triangle. Number 2, they want us to classify in 2 ways, right? So equilateral and also acute. And the other one, because one way has to do with the sides, and the second way has to do with the angles, right? So one, all the sides are equal, so all the angles are equal, and they're all less than 90, so it's acute and equilateral. The second one angle is bigger than 90, so it's obtuse, and all the sides are different, so it's scaling, right? Number 3, we have 2 sides that are the same, so it's isosceles, but all the angles are less than 90. So it's acute again. And then for B, find the measure, you just do all of them add up to 180, right? So you find the difference. So that's 1 through 6. Now let's look at number 7. 7 has this funny figure there. Okay. Like this. Alright, and this says 55 and 35. Alright, what are our, we have A, B, C, and D. Okay. You see how we're naming a shape? We just do it by the corners, right?
Yeah.
So if we want a triangle, we have 3 corners. If we want a quadrilateral, we have 4 corners. Okay, so this is 55 degrees and 35 degrees. Okay. And it says 8 centimeters here and 14 centimeters here, right? Okay, so the first thing I do, I look at this angle, this triangle. I see these two, it means I can get this one,
Yeah.
right?
It's 90.
So it's 55 plus 35 is how much?
90.
90. So that means the other one is also 90, right? Because they add up to 180. I don't know if I'm going to need that, but I'm just going to put that in straight away. So now what it says is, if DAB, so the way you can do angles is you can do, just like you can make a triangle, if you do the name of the angle with the 3 letters, okay, the angle is what's formed between them. So angle DAC equals 55. It's DAC. You see that? Angle,
What does sign mean?
pardon?
What does sign mean?
This?
Yeah, greater.
It's the angle.
Angle.
So here we're using it as an angle, not as a greater than or less than. It's a bit confusing because it's the similar sign. What might be helpful is if I do it like a bit bigger, like that. Is that helpful? It's not quite the greater than.
Sometimes we do
Yeah,
it.
I
Yeah.
understand now.
Yeah, it's not quite the same. The greater than or equal is a bit smaller, and the angle's kind of like up. But they look similar.
So it looks different than this.
Yeah, ADC. What is angle ADC?
A, B, C. It's 90.
Is 90. So you go A, D, C. So it's this one in between.
Yeah.
Okay, so that's 90. I should put degrees, 90 degrees. Okay, so now what this one's telling us is it says angle, what is it? Angle DAB equals 115 degrees, right? And angle, angle DCB 95 degrees. Okay, so DAB is this one,
Yes.
this big one, all right?
Yeah.
So what that means is these 2 angles together add up to the big one, right? You see how it's split?
Yes.
So you add them together. So that means we should try to find what is angle BAC. Right? We want this angle here.
Yes.
So if angle BAC, it's this one's 35 here.
Yeah.
This one, we know 55.
55.
So DAB equals angle DAC plus BAC.
Yes.
Do you guys see that?
100.
DAB equals DAC
Yes.
plus BAC.
Yeah.
It's this one plus this one,
Yes.
right? Does everyone see that?
Yeah.
Imad, you see that?
Yeah, I see.
Yeah? Okay. So this one plus this one. So we know DAB is 115,
Yes.
right? DAC we have here is 55 plus an unknown. So let's put x. Right? We don't know what this is. We solve for x. Subtract 55 from both. And x equals 60. Alright, so this one is 60.
Yes.
And you can see that 55 plus 60 equals 115.
Yeah.
Alright? In the same way, we're still missing, we need to find ACB, right?
Yeah.
So what is angle ACD, right? And that's going to equal basically 95 minus 35, right? Because whatever, this whole thing is 95. We have that here. So this one is the 95 minus 35, which is what? 60. Alright, so we know that this is also 60. If this one's 60 and this one's 60, what's this one?
This is also 60.
Also 60. Alright, what kind of triangle is this?
Right.
All
Acute, yes. It's not a right angle, it's acute. But what's the one for all sides are equal?
yes, all sides are equal.
Equilateral.
Equilateral.
Equilateral. So if all the angles are equal, then all the sides are equal.
Yes.
That's the thing with the triangle. If all the angles are equal, it's an equilateral triangle. All the sides are equal. Now the question is asking, what is the length of AC? Okay, 14. Because this is 14, so this one must be 14.
Yes. Next one also 14.
Alright, so we do 14. And that is number, let's see. You see, it's like a puzzle. Right? You do a step at a time. You have some knowns, and you have enough information
Yes.
to find the other parts. You fill them in until you figure out what you're looking for. Any questions on it? It's basically how you do these kind of problems. Alright, I'll take a picture. Any other questions on this? Let's see, yeah, so number 8, it asks what kind of triangle. What kind of triangle is this? ACD. What triangle is this one?
Q.
This one is not acute. It has a right angle in it.
What? Which
ACD.
one?
Yeah, this is acute. This one. It says ACD. You have to make sure you catch each piece.
kind of triangle, yes.
What kind of triangle is it? It's not isosceles. Isosceles has equal sides.
Right angle.
Right. It's a right triangle. So it has a right angle in it. If it has 90 degrees, it's a right triangle, which is C. Okay? Alright, any other questions from the homework? No? Alright, let's take a break a little bit early, then we can start on the lesson afterwards, alright? Alright, so let's get started again. We'll start with the Pythagorean relationship.
I don't know.
Okay. So this is named after a guy, an ancient Greek man. Okay? His name was Pythagoras. That was the name, Pythagoras. And he loved geometry. The ancient Greeks did a lot of stuff with geometry. And whether he invented it or not, we're not sure. Some people say, no, the Babylonians already knew about it, but they didn't express it clearly. Other people say he invented it, but he wrote it down. All right? If you write something down first, you will often get your name attached to it, even if you weren't the one who invented it. So he wrote it down, and so we call it the Pythagorean, because it's from Pythagoras. And basically what it says is it's something relating to right triangles. Okay? So this is a right triangle, right? A right triangle. And what he says is there's a relationship between the sides. Okay? So we call this A, and this B, and this C, it's basically A squared plus B squared equals C squared. Right? That's the formula. So you guys probably know, you've probably encountered this before, but this is basically the formula. And there's all variety of different questions that can be related to essentially using this formula. Right? So one of the easiest ones is if we have a right triangle, the standard one, if this is 3 and this is 4, okay, then we can find C. So we do 3 squared plus 4 squared equals c squared. Okay? So what we do is we can first add these together. It's 9, that's right. 16 equals c squared. 25 equals c squared. We take, to get now c by itself, we do the same thing to one side as the other, right? So we square root both sides. Okay? Square root of a square is the thing itself, c. Square root of 25? 5. That's really cool. Okay?
5 squared is 25.
5 squared is 25, yep. And it works for a bunch of other ones. Most of the time you won't get a nice even number. Right? Most of the time it'll be a decimal. Right? So you're going to be using your calculator for this. Do you remember the square root? Pardon?
Show us how to use calculator.
Yeah, alright. So say we have, you can draw almost any right triangle, with any combination, okay? So say this one is now 4, right? And this one is 6, okay? And we want to know what is this. Okay, so it's the same thing, 4 squared plus 6 squared equals c squared, right?
Yes.
What's 4 squared? 16.
16,
36.
36 equals c squared. Okay, what's 16 plus 36?
52.
52 equals c squared. C equals square root 52. Okay? Now there's two ways you can do this actually. One is you can break up 52 into something that might have a square. Alright? So we can say this equals 52 is 13 times 4. Alright? And 4 is squareable. Okay? So this is the same as square root of 4 times square root of 13. Right? And square root of 4 is what?
2.
So you can kind of write it a bit like a variable. 2 square root 13. That's sometimes how you can write it. But, like you guys said, let's do the calculator. So pull out the calculators. Or your phone app in the calculator. Pardon? Yeah, because square root 7 is 49, and 8 is 64. So it'll be 7 point something. Yeah. That's actually how they used to do it. They'd find the nearest one, and they'd do the decimals next nearest of like the decimals, and they'd figure out each decimal by what's the closest square root. But now we have a calculator which I think stores a table of all these square roots and can find it for us. So what you do, you have it here, okay? Your square root symbol, if you see the little x squared,
Okay.
right, above it is that little check, a little yellow check symbol, right? There's your square root symbol. So you do second, because you have to do second to get access to it. So second, square root. Does everyone have that symbol?
Okay, yeah.
Right?
Yeah.
And then you put 52 inside,
Yeah.
and it'll give you an answer, right?
2 radical 13.
So it's basically second
X
x
squared.
squared 52 equals
2.
7.2111. Okay?
Gives 2 times.
See, that one solved it like here. If you
Yes,
put maybe more, there you have the other option.
But which one is the answer?
Pardon?
Which one is the answer?
Depends on what is written in your book. If it has, both of them are correct. 2 square root
This is
13.
correct, yeah?
This is correct. But what you could do is maybe push this button, and it'll give it to you in decimal. You see, they're the same. Okay? So I would write this probably rounded to the second decimal, so 7.21. Alright? That makes sense, because we said it's between 49 and 64. So it'll be 7 something. Does everyone see how to get this?
Yes.
Yeah? Alright, so that's how you're doing square root. That's basically what you're going to be doing with these kind of problems. Alright, so let me say actually, there's one other thing, which is the labels, right? A and B are called legs. Okay? And C has a special name called a hypotenuse. Did I spell that right? Oh no, no E. Hypotenuse.
Hypotenuse.
That's also from Greek. It doesn't
Name
look.
also.
It doesn't look like an English word.
The name, no?
Yeah, it's the name. Basically, hypotenuse is the name for the line which is across from the right angle. Okay? It's a very important relationship. It's a word you need to know. Because they'll say, what is the length of the hypotenuse? Right?
Okay.
And you might know, what do they mean by the hypotenuse? It's the one that's across from the right angle. Okay? So this is here's the angle, the hypotenuse. It's always the longest line. Okay? It's always the longest line. And it's what's across from here.
Like
Yeah, these are legs.
hypothesis.
It's like hypotheses.
Yeah.
It's similar because it's the same Greek hypo.
Yeah.
I think it means like under. So hypotheses means it's you're under consideration. You're
Yeah.
thinking about it, right? Hypotenuse, I don't actually know the rest of the Greek for it, but it probably is something like it's under the angle maybe. It might be from when it's like if you draw it like this, right? Then this is the line under the angle.
Yeah.
Maybe that's where the original name of the Greek comes from. But it's basically, yeah, hypo. So any word in English that has hypo or hyper in it is coming from Greek. Hyper is over, hypo is under. You have hyperactive. You've heard of hyperactive? A child can be hyperactive. They're just busy all the time.
Hyperprocess.
Pardon? Hyper process. Yeah, hyper is like above.
Yeah.
And hypo is under. So yeah, if you think about it, it's under the right angle. That helps you remember the name. Okay, it's basically the one that's across from the right angle. I want to show you something else. One other important relationship, Pythagorean relationship. And that is, if we have, oh, I should have kept A, B, C. So if we have, let's see, so again, it's A squared plus B squared equals C squared. There's one special kind of triangle you can have. Okay? 4, 1, 2, 3, 4, yeah. Right? And that is a isosceles right angle,
Yeah.
right triangle. That means it has a right angle and these sides are equal.
That is good.
Okay?
Two side equal.
Two sides are equal, yeah. So it's a right angle. So that means immediately I know what these two angles are.
30. Which one?
No,
This
Try it
is
again.
No, 45.
45.
Yeah,
That's right.
45.
Right? Because if this is 90, so these two also equal 90. And 90 divided by 2 is 45. So that means in this isosceles right triangle, right? The angles are 45 degrees. Okay? And this here, let's try it, right? So it's a squared plus b squared equals c squared, right? So this is going to be 1 squared plus 1 squared equals c squared, which is 1 plus 1. So it's 2 equals c squared. So c equals square root
Of 2.
of 2. Okay? So you can do that in your calculator. It should be something like 1.4. Maybe 1.41 or something. You can try it. Calculator.
Yeah, 1.41.
2 equals 1.41. Yeah. 1.41. So this is an interesting relationship. This has 45 degrees, 45 degrees, and this is square root 2. So 1.4, right? So you can see, okay, say for example, you know this sort of is true, but say for example I want to go to this part of the room, right? I know that it's shorter to go straight this way than to go like this and then turn, right? So you can see here is 1 and 2, but this is square root of 2 to get there. So it's kind of there's actually this relationship that you can kind of calculate between these things using this kind of relationship, the right angle triangle. The other thing that's interesting with this one is if you have a square, right? Right? And you cut it in half, right? Oops. You cut it in half, it forms two of these right angle isosceles triangles, right? So you can kind of, you know that the line, diagonal line of a square is square root 2 of whatever the edge is. Right? So if this is 4, then this is square root 2 times 4. It's like one of these important sort of triangles to know. There's one other one that's interesting, and that is when we have this is 90, this is 60, and this is 30. Okay? And the interesting thing with this one is that I think, let's see, this is 1, and this is 2. Okay? This is twice this one.
Yes.
And this is a square root. We can figure this one out, okay?
Yes.
Let's say that's b now, right? So 1 squared plus b squared equals, oh yeah, this is square root of 3.
Two.
And we'll find it out. We'll find out. Equals 2 squared, right?
Yeah.
Okay. So therefore 1 plus b squared equals 4, right? So b squared, we subtract 1 from both sides. B squared equals 3.
Yeah.
So b equals square root 3.
3.
Okay? So that means this is square root 3. So that's another interesting relationship. Right? And it's got some nice numbers. If you have 60 and 30, then this one is 2 times this one. And then this is square root 3, which is also a fairly nice number. Now these become useful in something called trigonometry, which we're not doing for the GED. But it's something called sine and cosine and tangent. I don't know if you guys encountered this in some of your mathematics.
I remember.
Yeah, it's a way of finding lines from these things, and it's actually it's been very useful for finding direction, right? So trigonometry was greatly developed by the ancient Arabs, specifically for finding the direction to Mecca, because they had to, like, wherever they were, they had to sort of position by the stars to find the exact location on the globe. So they kind of developed that mathematics. Unfortunately, we're not doing that because we don't have enough time to do everything. And the GED doesn't require us to do
But
trigonometry.
it's in high school.
Yeah,
Yeah?
it's
Yeah, it is a high school math, but the GED is doing a certain level that you don't need to have it to do the GED test. But it is, like, for sure, if you want to do more mathematics, you will encounter trigonometry. And trigonometry is all about right triangles. It's a way of doing measurements of angles according to these. And so what they have is a relationship of the line, the side, to the angle. Is the trigonometry. So 30 to 1 is a certain relationship. And it's like this one over this one to this angle. It's kind of what trigonometry deals with. But we're not doing it. So if you want to, you can look into it. It's called trigonometry.
Yeah.
I'll write it down.
After this, so where can we get this trigonometry?
Trigonometry. Where do you think I will point you to get free education from math? Khan Academy, exactly. If you want to learn trigonometry, Khan Academy has it. You just type in trigonometry and you'll get the lessons.
No, everything.
Yeah, it has everything. So seriously, if you want to learn more of this, like trigonometry, he'll go through the lesson for you. Like, absolutely. Learn more than we have for the GED. Absolutely. Please do. It's good. And this is the beautiful thing, I think, with Khan Academy. It's free education. But they have these videos, they have these questions. You can practice over and over. Anything you want to learn, you can go there and learn. So yeah, for sure, go to Khan Academy and learn about trigonometry. But focus on the GED first.
Yeah.
Finish the GED. But I think like if you did the SAT or something, you probably will have some trigonometry on it. All right. Any more questions on right angles and Pythagorean relationship? Okay. And we're going to go on to the next section. Just do a picture. Alright, I'll just give you a little example of how trigonometry would work, okay? So say you are in the desert or somewhere, okay? And you know that at the middle of the day, right, the sun is at its highest point in the sky, right? And so say, and you also know the middle of the year, there's one day a year where the sun is the highest, right? This is called the solstice. It's the longest day. Remember we talked about this a while back. So you know what you can do is on the solstice, the one day is the longest, you can take a measurement at 12 o'clock, and you know that that's the highest point the sun is. So say you're here on the earth, right? And you measure, here's the sun, okay? And for you, it's basically a right angle, and you're here. So you can measure this, okay? And this way you can tell, if you know, it's basically, I'm drawing this like round, but really because you're so, basically the earth is flat. For here. It's so big, it's like a flat surface. So you know it's a right angle to the sun here. And what you do is you take a sextant, or thing that measures the angle here, right? So if we measure the angle here, then trigonometry can tell us, based on this angle, right? And this relationship, it can tell us what that distance is. So it's a way of finding distances, of measuring them. There's more to it, but this gives you an idea of why the right triangle is so important. And you can also measure stars. You can measure the North Star. It's a way of navigating. And this way you can tell on the Earth, right? You measure the North Star and you can tell what your latitude is based on how the angle of that star. You know where you are on the globe. So you can know if you're far north or south. And you can get the exact line that you are in the north and south angle. So it's a way of navigating, but only up and down. Lengthwise, they had to use clocks, actually, to figure it out, to tell when was noon. All right, that's a little bit of a history of science, or history of math. Let's do the next section. So we'll start with perimeter. Alright, so say we have a rectangle, okay, or any shape. The perimeter is what is the combined length of all the sides, alright? So if this is 6 and this is 4, this is a rectangle, say, then it means this is 6 and this is 4. So the perimeter the 6 plus 6 is 12. 4 plus 4, the 6 plus 4 plus 6 plus 4 equals 20. Let me get a different marker. This one, maybe? Yeah, there we go. All right. Perimeter. Also, guess what language that comes from? In Greek. Right? Peri means around, and meter is like to measure. Right? We know meter is like the length. So peri is basically around. I'm not sure what other words are in Greek that have peri. In English, it still have peri. Perimeter. Yeah, that's it. Really it. But so it's basically the length of the border. Okay? So it's all four. So for a square, right? So this is S with S, S, S. Perimeter of a square equals 4 times S. Right?
Yes.
This is 4 times. For a rectangle, this is B, this is A. A rectangle equals 2 times A plus 2 times B. Or we could say this is length, right?
Yeah.
Let's call that L. We're going to do it cursive so it doesn't look like an I. And width. So 2 times L plus 2 times width. Okay? Length times width. Or this is maybe height or something like that. Alright. What else do we have? Triangle. Triangle is pretty basic, right? It's just all three together. Yeah, triangle. A plus B plus C. Okay? Now what's interesting is if you have a parallelogram, remember what parallelogram was?
Yeah.
This one and these are parallel, and these two are parallel. Right? The parallelogram will be the same as a rectangle. Right? Because these two are the same, and these two are the same. A diamond will be like a square, because they're all the same. Okay? A trapezium, you have to know all the sides. Because the trapezium doesn't need any side to be any length. So you just have to know all 4 sides to get the trapezium length. But any questions on perimeter? It's fairly straightforward, I think. But you just add these. And you have these formulas, and they're actually in the formula sheet. So when you do the GED, you'll have the sheet, and it has these formulas. Let me just check our sheet
Yes.
on page
413.
413.
Yeah, 413.
Yeah, so it says perimeter. And you have square, rectangle, triangle, and the circumference of a circle. We'll do that either today or next week, depending on how we're doing. Okay? The next one is then, yeah, I'll take a picture. Perimeter. Yeah, we're getting close. The next one is something called area. So perimeter is basically the lines. The area is something that's like the flat region it fills. Okay? So an area, if a perimeter is measured in meters or centimeters or kilometers, right? An area is measured in meters squared or centimeters squared or kilometers squared, or miles squared or feet squared. That's what they'll probably give you because they're Americans. Okay? Or feet squared, miles, square miles, that sort of thing. And that's basically because you're looking at, say this is 1, 2, 3, 4, Alright, say we're looking at something like this. It has 4 and 5. Okay? What you're imagining is little squares inside. Okay? If you were to count these, it would be 20. You have 20 squares. So 4 times 5 equals 20. So what you're imagining is each little one here is a squared whatever it is, right? So if this is a centimeter, then this is a square centimeter, because there's a centimeter on each side, right? Equals 1 centimeter squared, right? So when we're measuring area, we're measuring how many of these little squares are inside the shape, okay? And so what we do is we multiply the sides, and that'll give us how many? So this one equals 4 times 5, which equals 20 centimeters squared, or 20 squares. Is that clear how it works?
Yeah.
All right. So now what we have is we have these different shapes have specific formulas for how we can find the area inside them. All right. So the first one is square or a rectangle. They're the same. Okay. Here is the. Let's start with the square. We'll start with the square. This is S, right? S, S, S. Area of a square equals S squared. And that's why it's called squared, actually, because it's S squared. And the same reason why a cube, which is if we take the same length out, the volume of a cube is S cubed. That's why we say cubed, because this relationship. So S squared is the area of the square. Now if we have a rectangle, right, this was length and this was width. So the area of a rectangle equals length times width. Okay, whatever this is, times this one. So those ones are fairly straightforward. Now what about some other shapes? Next question can be, what about a triangle? All right. What you do with a triangle is you take this piece here and you draw a line down from it. Okay? And that is the height. And this one here then is called the base. And the area of a triangle exactly equals 1/2 base times height. Right? And now let's look at this. Let's see why that works out that way. So if we draw this triangle, okay, I want you to imagine there's actually a square or a rectangle around it, like this. Okay? And then let's draw that height down. Right? Can you see that this triangle here would fit in here? You see, you take this piece, you flip it, and it would come here. Right? So then this is a rectangle here. Right? And the area of the triangle would be this rectangle. And this rectangle is half of the whole one. So that's why we do half of the rectangle made by the height times the base. Alright, so we say here's the height, this is h, and here's the base. So the area of this rectangle is h times b, right? This length times width. But the triangle is half of that. So it's half base times height. Okay? Now what about a parallelogram? Doesn't look quite right. Like that. Yeah. So now this is length, and this maybe is width, but we're not going to do it this way. We're going to do base, okay? And we're going to do height. So what you can have here, you imagine like this, okay? And the area of a parallelogram is actually really interesting. It's basically height times base. All right? Let me just check that. Yes. So we don't actually worry about the length. Sorry, this one here. We don't worry about this one here. Okay? The area of the parallelogram is base times height. So you make an imaginary, let me show you why that's the case. So let's say we have a parallelogram here. There we go. Okay? And again, we're going to draw this dotted line out. And imagine taking a line down here. Right. You can see this triangle here would fit in here. Okay? Because it's a parallelogram, you know that this angle equals this angle.
Yeah.
This length equals this. So you can just imagine taking this piece and putting it here. And then what we're finding, if this is the base, this piece here will equal this here. Right? This is the same length as this one.
Yeah.
Yeah.
So base, and then height is here. So the area of this rectangle is base times height, because that's a rectangle. So that means that's the same as the area of the parallelogram. Okay? So one of the type of questions you may have is something like you get the parallelogram, they give it to you like this, and they tell you the base, and they tell you this length here. Right? And then they may tell you, if you're trigonometry, they might tell you the angle here, and you'd have to figure out this length here. But they won't tell you the height, okay? They'll tell you this here, A. They'll tell you this little amount here. And you have to figure out the area of the parallelogram. So what you do is you use the Pythagorean theorem, because this is the right angle, right? So then A squared, and this is height. We don't know what height is. A squared plus H squared equals L squared, right? Then you solve for H, and then you do H times B, and you get the area of the parallelogram. That's the kind of question you'll have, where they're kind of putting them together. Is that clear? Okay, let's do another one. Let's take a picture of it. Erase those. Okay, we can do that too. Let's do, we're still doing area. That's the wrong marker. Let me try purple. Nope. The other purple. Yeah, there we go. Okay, so now, how about a trapezoid? Right? So here we have base. And what we have with the trapezoid is we have to do both bases. Okay? And we use the height. Height. Alright? And the area, trapezoid, is 1 over 2, base 1 plus base 2 times height. Alright. So that's our area, and I'm going to prove it to you. Okay? So let's take a trapezoid, any trapezoid, like this. Alright? And what you need to say is, here we have our height, right? Let's draw down both sides. Okay? So here is height, and here is B1, and this is B2, right? So, first of all, we can calculate the area of the inner one, right? Inner rectangle equals B1, oops, the one should be done. B1 times the height, right?
Yeah.
Okay, Now here we have some triangles, right?
Yeah.
So the triangles, what we need to imagine with the triangles is we need to find out what this distance is, right? Right? So here we know that this is,
Right angle triangle.
yeah, we have a right angle here, right? And what we need to think of is basically it's B2, right? Minus, let's call this one A, right? And this one C, right? So A equals B2 minus B1 minus C, because this is B1, right? This is B1, and this is C. So actually, let me make it like this. Minus, let me write that so it's more clear. Okay, so it's B2, the whole thing, right? Minus this piece,
Yes.
right? And this piece is B1 plus C. Minus B1
Plus.
plus C. Okay?
Yes.
So this is A. So we know the area here. So this, let's call this one area 1, area 2, and area 3. Right? So area 1 we know is B1 times H. But I'm just proving this, okay? You're not going to have to do this calculation again, but I want you guys to see where this formula is coming from. All right, so here we have A. So area 2 equals, what's the formula for a triangle?
Half.
1 over 2
Yes.
A
Yes,
times
nice.
H, right?
Yeah.
Okay, so we'll put this in a little bit. Let's just leave it for now like this. And then let's try and find C is also B2,
Yeah.
right? Minus B1 plus A,
Yes.
right? Okay, and area 3 equals 1 over 2 C times H, right? This triangle here. Now what we have is we actually have 3 equations, right? But they're all interrelated. And you'll find when we put them together, they're going to work. So first of all, what I'm going to do is I'm going to write everything in terms of A. Okay? So let's first put this one. So here we have A equals B2 minus B1 plus C. Now we have C here, right?
Yeah.
So let's put that in. Plus B2 minus B1 plus A. Double bracket. Okay, do you see that? This is C. This is C. Right? The C here is this one, and I put it inside here. Right? Now we can simplify a little bit. Right? B2. First we do this bracket. You do minus B1 plus B2 minus B1 minus A. Right? Okay. Yeah, like this. Okay. So then A equals B2 minus B1 minus B2
Plus
plus
B1.
B1. Oh, I'm just going to get A equals A.
What was that?
Yeah, it's not going to work out so well. I think what I need to do is switch it. Let's try to write them. Let's see. Yeah, this isn't quite working. Right, so I'm just going to get minus B1 plus B1. Yeah. Plus A. These are all going to cancel. I'm going to get A equals A. That doesn't help me. Does it? Let's see here. Perhaps we can write it in terms of well, I know what to do. We'll do here, right? B2, our problem is that B2 equals A plus C plus B1, right? Now when I did this, I did it a different way, which was what my problem was. I think what I did was I used a different trapezoid. Let's see. I did this kind of a trapezoid. Ah, yes, that's how I did it. Let me redo this problem. Sorry, I should have looked at my notes. Okay, let's start over. Start over here. Okay, so we have this problem here. This is A. So what we need to do is we need to imagine if we take this is the same as essentially take this triangle here and put it here. Okay? So this is now A2, A3, right? And this is a parallelogram. So you take this triangle here, okay, and you put it here. And this is B1, and this is also B1 here, right? And the whole thing is B2. Okay? So that means this is B2 minus B1. This area here. And this is a parallelogram, because I put this triangle is the exact same angle. Okay? So it's a parallelogram. This is A2. And I put A2 over here. Alright? So now what I have is I have a parallelogram and a triangle. Okay? And I'm saying this trapezoid is composed of a parallelogram and a triangle. Now the parallelogram I can get the area of, right? So we have height, and this is B1, and this is B1. So this is A1 equals B1 times H, right? The area of the parallelogram. Remember what that is. And now here this triangle is H times whatever this is. This base here, right?
Yeah.
So times this unknown base. So this here, A2, I'll call it A4 actually so we won't be confused. A4 is the whole triangle, right?
Yeah.
So A4 equals B unknown times H over 2, right?
Yeah.
This is a triangle. And now the question is, what is B unknown? B unknown is B2 minus B1. Because this whole thing is B2, right?
Yeah.
We subtract B1 and we get this thing here.
Yeah.
So now we have A4 equals 1 over 2, right? B2 minus B1 times H. Okay? Everyone agree with this?
Yeah.
Yes.
Okay, so that means the total area is A1 plus A4, right? The area of the parallelogram plus the triangle
Yes.
to get the whole trapezium, or trapezoid. So that means area equals B1 times H plus 1 over 2 times B2 minus B1 times H. Okay? So this equals B1 times H plus 1 over 2 B2 times H minus 1 over 2 B1 times H. Do you see that?
Yes.
Now we have B1H minus half B1H. That will equal positive half B1H. So that equals 1 over 2 B1H plus 1 over 2 B2H. Okay? Because this one plus this minus this one equals a half. Right? 1 minus a half is a half. Now we can use a distributive property, and we get 1 over 2H is in both of them. B1 plus B2, which is our formula. Alright, sorry, I should have looked at my notes. So this is how we get the area of a trapezoid. Now you don't need to do this calculation again. You just need to look in your formula sheet, and it has the formula there. But I like to do this so that you can know where does this come from. So you can feel secure in the formula, right? You know where this formula came from. You can see it comes from doing these two triangles. And it's also kind of a good exercise in mathematical thinking. All right. So a lot of times, what you're going to have to do is they're going to ask you for perimeter and this sort of thing. You'll need to find the height. And you'll often have to use like a right triangle with the Pythagorean theorem to find the height or these pieces. You kind of cut them in two. Let me do this one. All right. I think we have time for the circles as well. So I'm going to move us forward. And we'll do circles. This one? Yeah. Alright. So here's a circle. Right? So basically what a circle is, the definition of a circle is the line of all the points that are the same distance from one point. Alright? So I have this point and I say I want, two centimeters away from this. Okay? So I can draw this is 2 centimeters, this is 2 centimeters, this is 2 centimeters, this is 2 centimeters, this. And if I keep drawing them, all the points that are exactly 2 centimeters away will eventually form a full circle. Right? That's basically the definition of a circle. And so what we have with a circle is essentially this thing that's the distance itself. It's called the radius. Okay? So the circle is always defined by its radius. That's the central value for a circle. What is the radius? So we have the radius of the circle. And now, what's interesting is if you take, so we take the radius. Now we also have in a circle, we have something that's the full line that goes through the middle. Like this, right? That's like two radii. There's a radius here and a radius here. And this is called D, diameter, that's right. And in Greek, dia is from like 2 to cut in 2. So the diameter is the thing that cuts the circle in 2. Okay? So we have a diameter. And now what's interesting is that if you were to take a measurement of the radius, of the diameter, okay, take it like this, and you try to draw it around the circle, okay, you'll find that it goes 3 times and a little bit more, okay? And the amount that the diameter, so we have a diameter here, maybe 1, this is D, this is another D, this is a third of a D, and here's like some fraction of D. some fraction of d. Okay? And what this number of times the diameter of a circle goes around its circumference, if you take a thread, this is a special number called pi. Okay? So, diameter around a circle is this Greek letter called pi. Alright? So circles are defined by pi. It's interesting. Any circle, no matter how big or how small, it has a relationship of the diameter of the circle, so the 2 times the radius, to the edge of pi times d. So we call it the perimeter is the circumference. Okay? The circumference. That's basically the length of the part around the circle. Okay? And the circumference of a circle equals pi times d, or 2r times pi, because diameter is 2 times radius, right? Radius is this one, so diameter is 2. And pi is a special number. It's a very special number. It's basically, it keeps on repeating. So if we were to kind of do this calculation, pi equals 3.14259 ... It keeps on going and never repeats. Right? These decimals just keep on going backwards and they never repeat. And people have done calculations of pi to like thousands and thousands of decimals, and they find that it never repeats. They keep on trying. So it's a special number, pi. And it's a number that exists outside of any measurement. Right? It just exists in sort of the mathematical world, in the universe. There's this relationship of any circle, perfect circle, which is any amount of dots a certain distance. The amount of dots, the length of it, will always be pi times twice that radius. It's a fascinating connection, okay? So if you want to find the radius, the circumference is 2 pi. 2 pi times the radius. And there's one last thing that you need to know, and that is the area of a circle is pi radius squared. Okay? Now usually what we do in math is we use pi, we say it's roughly equal to 3.14. Okay? We round it to 3.14 and use that as pi. Now it's not 3.14, it's 3.14259, etc. Okay? But for simplicity we use 3.14. So if you're trying to find the area of a circle, and I gave you a circle here, and I told you that the radius is 2, all right? And the area would equal 3.14 times 2 times 2, right? Which is equal to basically around 12 something, right? You do that in your calculator. If I gave you this circle, and I said this is 5, the diameter is 5,
Yes.
okay? Then the area would equal pi times 2.5 squared, because it's half of this, remember? Don't make this mistake, all right? It's the radius, not the diameter. So the full diameter is 5, so the radius is half of that, 2.5, okay? And the circumference would equal 5 pi.
But it's the same answer if we do with the diameter. 5 times 5.
Because that's diameter. But this one is 2. The circumference here equals 4 pi. It's 2 times 2. This is the diameter times
Yes.
pi. All right? Or 2 times the radius. Any questions on circles? This is basically the formula. I'm going to give you the 3 pages of homework to practice. There's not a lot of questions on each page, so you can do it. Okay? And we'll come back the next week and practice these. Any questions? All right, your homework is page
I'm taking
393 whole, page 395 whole, and page 397. Okay?